functional equations, as well as being great fun, are fairly common in Maths Olympiad and college entrance exams. So what we got here is a question where the unknown is the function itself, and that's basically what is meant by functional equations, is that basically the fx itself is the unknown. So question 1 is solve fx squared minus 4fx equals tan squared x minus 3. Okay, now we're going to do 2 methods to solve this, and then afterwards we're going to do another question, and we're going to show 3 methods how to solve that, one of which is an awful method in my opinion. Okay, so let's have a look at method 1. Let's draw a line down the middle here so that we can put the 2 methods. Okay, so this looks fairly similar to a quadratic, and that's actually how we're going to solve it. Now you don't need to do these 2 substitutions. Let's let fx equal y, and also let's let 3 minus tan squared x equal c. And you don't need to do these, but you'll see why I do it, because it does make it, the first time you've seen one of these, it makes it a little bit easier to understand. So basically we then have y squared minus 4y, and then if we move this over to the other side, we have add c equals 0, which is a very, very easy to solve quadratic. So then we solve the quadratic using the quadratic formula. So we have y equals minus b plus or minus the square root of b squared minus 4ac all over 2a, which gives us y equals 2 plus or minus. Now just the only reason I put the c in was so that people would understand. We can now put the substitution back. So we got plus 2 divided by 2 plus or minus 4 minus c, which is brackets 3 minus tan squared x. All I've done is I've put the tan squared back in there. So we have y equals 2 plus or minus the square root of 1 add tan squared x, and 1 plus tan squared x is sec squared x. So we have y equals 2 plus or minus the square root of sec squared x, i.e. y equals 2 plus or minus sec x. And that is the answer. Well, sorry, and then of course y is f of x. Sorry, we did the substitution. In actual fact, the answer is f of x is 2 plus or minus sec x. Now, there's actually a nice quicker way, even quicker than that, is that we can complete the square here. And this time I won't bother doing the substitution. So basically, looking at this side here, we can write that as f of x minus 2 squared. Well, that would be fx squared minus 4f of x add 4. So we've got to take away 4 again, equals tan squared x minus 3. And then add 4 to the other side gives us f of x minus 2 squared equals tan squared x add 1. And then when we take the square root, we get f of x minus 2 equals the root of tan squared x add 1, which equals the root of sec squared x. So therefore f of x equals 2 plus or minus sec x. That's a slightly quicker way, gives the same answer, of course. Okay, now let's have a look at a more common version of this question, which is solve f of x squared add 4f of x equals a quadratic. This is where you tend to see it more. And the reason I've done these questions in this order is that you'll see that basically it doesn't really matter what is over here. The completing the square method or the using the binomial, not the binomial, sorry, the quadratic formula works. So let's have a look at method 1. Okay, well, method 1, again, let's have a look at method 1. We can rewrite this as f of x squared add 4f of x minus x squared minus 10x add 21 equals 0, and then we basically again use the quadratic formula. This is going to feel fairly similar. Equals minus b plus or minus the square root of b squared minus 4 times a, which is 1 times x squared minus 10x add 21, but as that's negative that becomes a plus, all over 2a, which equals minus 2 plus or minus, I'll take the 4 out, the square root of 1 add x squared minus 10x, sorry, that's a 4, isn't it? That's 4, 16, take this 4 out, it's 4, x squared add 21, which equals minus 2 plus or minus the square root of x squared minus 10x add 25, which equals minus 2 plus or minus the square root of x minus 5 squared, which equals minus 2 plus or minus x minus 5. So if we have minus 2 plus x minus 5, that gives us x minus 7. And if we have minus 2 minus x minus 5, that gives us minus x plus 3. And they are the two solutions. Now that's method 1. Okay, well let's have a look at method 2, which again is completing the square, and again is a little bit quicker. So what was the question again? F of x squared add 4 f of x equals x squared minus 10x add 21. So let's look at method 2, complete the square. We have f of x add 2 squared, and that means we have to take away 4 equals x squared minus 10x add 21, i.e. f of x add 2 squared equals x squared minus 10x add 25, which equals x minus 5 squared, and so therefore take the square root. F of x add 2 equals the square root of x minus 5 squared, which equals minus 2 plus or minus x minus 5, and that gives us exactly the same answer as that. Now, I do want to say actually a third method, which I think is an awful method, but which a lot of people seem to enjoy. I've no idea why. What they say is, well, look, as that is squared, and as this f of x is squared, therefore f of x itself must be linear, and so therefore we can put it in the form ax plus b. Well, you can, and it gives the right answer. The problem with this is, A, it only works if this is a quadratic. It certainly doesn't work if that's tan squared x or whatever. B, it's not absolutely certain that f of x is linear. It doesn't tell us that in the question. But anyway, let's give it a go just to show you. So basically what they would say is they would say, okay, by some magic, we're going to assume that f of x is ax plus b. And then what we are going to do is we are going to put ax plus b squared, add 4 ax plus b, equals x squared minus 10x add 21, which was the question. We're going to expand it out. A squared x squared add 2abx add b squared add 4ax add 4b equals x squared minus 10x add 21. Comparing x squareds, we have that a squared is 1, i.e. a equals plus or minus 1. And then if we compare the x's, we have 2ab add 4a equals minus 10. So if a equals 1, we have that 2b add 4 equals minus 10, i.e. b equals minus 7. And if a equals minus 1, then we have minus 2b minus 4 equals minus 10, i.e. b equals 3. And so therefore the solutions are, ax plus b would be x minus 7 and minus x plus 3. So of course it gives the same answer. I think this method here is awful because it only works for this one specific type of equation where that is squared and we assume that is linear. What you want to learn, especially for exams, is you want to learn a much more general method which will solve for anything, including stuff like this. Okay, well, I hope you found that useful. If you did, please like this video and subscribe to the Gresty Academy YouTube channel. Thank you.